morning, my dear students. Today we shall start with the next lesson. This lesson is from optics. What is optics? Optics is the study of light. So now onwards we will be studying light. Okay, so the first topic in the light is refraction at the plane surface. So we are going to start with refraction at plane surface. Now you have studied certain chapters in light in 9th class also. Okay, the first topic that you have studied was reflection. Today we will talk about reflection and refraction. Now what is reflection? What do you mean by reflection? Reflection is a phenomena of light in which a ray of light strikes a reflecting surface and bounces back in the same medium. Okay, so reflection means the ray of light is traveling in air, it strikes the surface plane mirror and then goes back into the air. This is known as reflection. Then you had also studied about two laws of reflection. The first law, the incident ray, the reflected ray, and the normal line one plane. The second law, the angle of incidence is equal to angle of reflection. So these two laws you had studied. The third thing that you had studied was that when a ray of light travels in air or in vacuum, then the speed of light is 3 into 10 raised to power 8 meter per second. Okay, so let us see what do you mean by reflection. Here, this is a plane mirror. The incident ray comes and strikes and then is reflected back in the same medium. So this phenomena is reflection. Okay, this is a plane mirror, this is normal, and a ray of light strikes at the surface and is reflected back into the same medium, so it is known as reflection. Then we come to another phenomena that we are going to start. When a ray of light passes through transparent medium, when a ray of light passes through a transparent medium, then it shows two phenomena simultaneously. One, you can see through that transparent medium, and the second, you can also see your partial image. Like for example, if you are walking across a showroom, you are walking across a showroom that has got a glass door. Now what can you see? You can see the beautiful person sitting inside the showroom, and also you can see your own image on the glass. Although the image may be not that bright, but still you can see a little bit of yourself in the glass, and you can see through the glass also. You can see the person sitting inside the showroom. So what is happening now? If you are able to see inside, it means the light is traveling through the glass. Okay, and if you are able to see the image of yourself in the glass, it means there is a reflection. So when the ray of light travels from one medium to another medium, then it is undergoing refraction, or it bends away from its path. So what is refraction? Refraction is a phenomena in which when a ray of light travels from one medium to another medium, it deviates from its path. This phenomena is known as refraction. Normally, whenever a ray passes from one medium to another medium, partially it is refracted and partially it is reflected. So both refraction and reflection are taking place simultaneously. Okay, but for this you need a transparent medium. Reflection requires only a mirror, whereas the reflection requires transparent medium. So look here, this phenomena, ray of light is striking a surface, a boundary, air and glass. Ray of light is striking a boundary. This side it's air, this side it's glass. Ray of light strikes here, it bends towards the normal. Now this is normal. normal. This is normal. So a ray of light is bending. It's not going, otherwise it would have moved a straight line like this. But instead it has gone down. And partially it is refracted, guys. So this is the incident ray, I. Okay, and this is R. And this is the reflected ray, reflected. And this ray is refracted ray. Okay. So what has happened here? The ray is partially reflected and partially refracted. The ray has reflected. Now you can see the ray is not moving in a straight line. When it has entered a denser medium, it has bent from its path. This bending of light from one medium to this bending of light from its path when it travels from one medium to another medium is known as refraction. Refraction is a boundary phenomenon. Okay, it takes place at the boundary which separates the two media. Okay, when a ray of light that travels from one medium, when it travels from one medium to another medium, actually it should be one optical medium to another optical medium having different densities, optical density, then it suffers deviation from its path. This phenomena is known as refraction. So we have the definition of refraction: the change in the direction of the path of the light when it passes from one transparent medium to another transparent medium is called refraction. It is a surface phenomena or boundary phenomena. That is very important. Okay. Now when we say it's a boundary, when it passes from one medium to another medium, it means the optical density of the two medium are different. So air and glass. Air is rarer than glass. Okay. So air is rarer than glass. So when two different media are there, then the ray deviates. Now here you can see the ray, we have got an incident ray, a reflected ray and a refracted ray. Now this is normal. What is normal? Normal is perpendicular to the surface. So you can see that when a ray of light is traveling from the air to glass, from rarer to denser medium, then it is bending towards the normal. Okay, the deviation is towards the normal. Or angle R dash. Angle R dash is smaller than angle I. Okay, angle R dash is smaller than angle I. Now if a ray of light travels from glass to air, what is happening here? It is moving from glass to air. Now when it is moving from glass to air, I, then the ray is bending away from the normal. So this is normal here. Normal. This is angle I and R. So when a ray of light travels from glass to air, it bends away from the normal. So they are reverse phenomena. When a ray of light is traveling from rarer to denser medium, it is bending towards the normal. When the ray of light is traveling from denser to rarer medium, it is bending away from the normal. Now what will happen if a ray of light strikes perpendicularly? If a ray of light strikes perpendicularly, then it will suffer no deviation. Okay? When a ray of light strikes normally to the surface, then it will suffer no deviation. Now for reflection to take place, the ray should obliquely strike a surface. If the ray is striking perpendicularly to the boundary, then it will undergo no deviation from its path. Is it clear? If the ray strikes normally to the surface, it will pass undeviated. Okay, here, if you look at the ray is striking normally, the angle is 90 degree, angle I equal to 0, therefore angle of reflection is 0. Okay. cause of refraction? Why the ray of light bends when it travels from one optical medium to another optical medium? This is the question. We know that the ray of light or the light travels in air or vacuum with a speed 3 into 10 raised to power 8 meter per second. Okay, but when it travels in any other medium, then its speed is changed, or rather it decreases, because as the optical density of the medium increases, the speed of light in that medium decreases. Okay, now we know that air or vacuum is the rarest of medium, or rather vacuum itself means there is nothing, so it is the rarest medium. So speed of light is maximum in vacuum or in air, and in all other material medium the speed of light is less than the speed of light in vacuum. Now when ray of light travels from air to glass, its speed slows down, so it bends towards the normal. And when a ray of light travels from glass to air, its speed increases in air, so it bends away from the normal. So this is the cause for the refraction. Then next we have laws of refraction. As we have the laws for reflection, similarly we have the laws of refraction. First one, the incident ray, the refracted ray, and the normal lie in one plane. This is the first law. They should be in the same plane, same 2D dimension. They should not be in 3D dimension. Okay, so when you are having the incident ray, the refracted ray, and the normal lying on the paper, the refracted ray should also be on the paper, should not emerge out. The second thing, the second law, the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. Okay, sine I upon sine R equal to constant. This is also known as Snell's law. So we have Snell's law here. Sine I upon sine R equal to constant. This is second law of refraction. Sine R upon sine R equal to constant, and that is equal to mu. Mu is refractive constant or refractive index. Okay, this is 1 mu 2. What are we reading it? Refractive index of the second medium with respect to the first medium. Okay, 1 mu 2 means refractive index of the second medium with respect to first medium. या हम कहेंगे, अगर ये हम बोलते हैं a mu g, this is read as refractive index of glass with respect to air. What does this mean? The ray of light is traveling from air to glass. Air से glass में जा रही है तो a mu g. Okay, air से glass में. अगर ray of light air से glass में जा रही है a mu g, और glass से air में जा रही है g mu a. So what is the second law? The ratio of sin I upon sin R equal to constant for a given pair of media. Now this clause for a given pair of media is very important, because this is a ratio between two mediums. Okay, ratio of two different mediums, because the ray of light is traveling from air to glass, air to water. There are two mediums that are involved. So it is for a given pair of media, it is constant. This is the second law of refraction. It is also known as Snell's law. It is also known as Snell's law. Then we have the definition of refractive index. The refractive index of the second medium. This is refractive index. What is it? Refractive index. refractive index of the second medium with respect to the first medium is defined as the ratio of the sine of angle of incidence to the sine of angle of refraction in the second medium. Unit sine r, trigonometric value. Sine r, trigonometric value. It's a pure ratio. Trigonometric ratios do not have any units. So refractive index is an absolute ratio. It has got no unit. Now effect of speed, frequency and wavelength due to refraction of light. So what is the effect? There are three things that we have. We have speed, V, okay, frequency, that is F, and wavelength. Wavelength equal to lambda. Okay. So when a ray of light travels from one medium to another medium, what is the effect on these three factors, V, F and lambda? Now actually we have relationship V equal to F lambda. Okay. There is a relation. Speed is equal to frequency into wavelength. Now frequency depends upon the source. What is the frequency of the light that is emitted out depends upon the source. So frequency does not change. The frequency of the light ray when it travels from one medium to another medium does not vary. Frequency will not change. Okay. Now what is left is only V and lambda. Frequency will remain constant because it is dependent only upon the source. And now what is left is V and lambda. Now we know that during refraction, the cause of refraction is different speed of light in different media. So when a ray of light travels in rarer medium, its speed is maximum, and as it goes into a denser medium, its speed decreases. So if speed will decrease, wavelength will decrease. If speed will increase, wavelength will increase, or wavelength is directly proportional to speed of light. Wavelength is directly proportional to speed of light. Okay, that is lambda is equal to F upon lambda is equal to V upon F, and F is constant. F is constant. So lambda is directly proportional to V. Speed of light will increase, wavelength will increase. Speed of light will decrease, the wavelength will decrease. Normally when a ray of light travels from air to glass, speed slows down, so wavelength decreases. Is it clear? When a ray of light travels from air to glass, which is a denser medium, so the speed of light decreases, so the wavelength will also decrease. Now the relation, when a ray of light travels from the denser to the rarer medium, then the speed increases, wavelength also increases. Okay. Then we have a speed of light in different media, relationship between refractive index and speed of light. Speed of light in air is maximum 3 into 10 raised to power 8 meter per second. Okay. Then it is represented by the letter C. The refractive index of medium is generally defined with respect to vacuum or air and is called the absolute refractive index. Okay, and we write 1 mu air. Air say glass में जा रही है, A mu G. So it is with respect to air, and it is known as absolute refractive index. So there is a relationship between the refractive index, speed of light in air, or speed of light in given medium. So refractive index mu is equal to speed of light in vacuum upon speed of light in medium. Speed of light in medium. So it's look here, mu is equal to C upon V. C is the speed of light in vacuum and V is the speed of light in medium. Okay. So suppose let us take an example that the speed of light in glass is 2 into 10 raised to power 8 meter per second. Speed of light in glass is 2 into 10 raised to power 8 meter per second. Then we will find out the refractive index of the glass. So refractive index of glass is here. We have to find out refractive index of glass, μg. Then speed of light in here, 3 into 10 raised to power 8 meter per second. 2 into 10 raised to power 8 meter per second. It is 1.5. So refractive index for glass is 1.5. Similarly, refractive index for water. Speed of light in water is 2.25 into 10 raised to power 8. Therefore, refractive index of water is 3 into 10 raised to power 8 upon 2.25 into 10 raised to power 8 meter per second. So, on cancelling we get 1.33. So, refractive index of water is 1.33. Okay. There is a table given in the book which you will find refractive indices of different material that are given. So from the refractive index we can find out the speed of light in different media. Okay, when we write A mu g, what does it mean? The speed of light in air upon speed of light in glass. When we write 1 mu 2 means speed of light in medium 1 upon speed of light in medium 2. Okay, 1 mu 2 means speed of light in medium 1 upon speed of light in medium 2. Or 1 mu 2 is also absolute refractive index of second medium over absolute refractive index of the first medium. Okay. Next we will continue in the next